Hi everyone, this is a tutorial on how to perform binary search. Binary search is a very efficient searching algorithm. The only limitation is that the array on which binary search is performed needs to be in sorted order. It doesn't matter whether it's in ascending order or descending order, it has to be sorted. So let's take an example where my array is 0, 1, 5, 6, 12 and 31. Let's add one more item, 40. The indices of these items are 0, 1, The basic idea behind binary search is that you have a target that you're trying to find. You take a look at the array and you pick the middle item. If your target exists at the middle item, it's fantastic, you found your item. But if your item is not the median item, then you have to make a decision on whether to look in the left half or the right half. Now you can do that because the array is in sorted order. Had the array not been in sorted order and you try to do the same for the target 7, you cannot do that because you don't know whether the 7 will be in the left half or the right half if it's there. So this highlights why the array needs to be sorted for binary search to be performed. So let's have an example where the item that I'm trying to search is 5 and the array is this. You're searching from 0 to index 6. The median is index 3. You compare your target with the median item. If your target exists there, fantastic. But otherwise you have to make a decision whether the target is in the left half or the right half. In this case, the target 5 is less than 6 and therefore it means that the target, if it's there, will be in the left half. You repeat the same process, but this time the array that you're going to consider is from index 0 to index 2 and the median value is 1. Again you make that comparison and check, is the target at median? If not, you make a decision on whether, if it's there, is it going to be in the left half or the right half. Now because 5 is more than 1, it's going to be in the right half because it's the right half items which are more than the median item. So now the array that you have to consider is only from index 2 to index 2. And in an array of single item, the median item is that as well. Again you make that comparison and you can see that the array contains that value, or the median is that item. So you can return the index 2. Another example where the item is 8. Your first median is index 3. So at stage 1, the median is index 3. 8 is more than the item at index 3, which is 6. Therefore, if it's there, it's going to be in the right half. The median of that part of the array is index 5. From 4 to 6, the median is 5. You compare 8 with 31, you can see that 8 is less than 31. So if it's there, it's going to be in the left half of that array, which means index 4 to index 4. The median of that array is 4 itself. And is 8 equal to 12? No, 8 is less than 12. So if it's there, it's in the left of that array. But there's nothing left. And therefore, you can say that the item 8 was not found in the array. Going into the specifics of the implementation, what you're doing is you're looking through the indices. So this is 0, 1, 2, 3, 4, 5 and 6. The indices are in green. You start with the first index you'll consider being 0 and the last index you'll consider being 6. You can easily see that the median index is computed as first plus last whole divided by 2, because that's the average. You make a comparison, and if your target exists at the median index, then you have success and you can return the median index. However, for an ascending array, if your target is more than the median item, it means if there, it's in the right half. Now, how do you select the right half of the array? All you have to do is relocate first from its current position to after median. So all you have to do is say first becomes median plus 1. Similarly, the only option left is if target is less than the median item. What it means is if the item is there, it will be there in the left half. And to do this, you need to move last to one before median, and last becomes median minus 1. This process of computing the median and then making the comparison should be repeated as long as first is less than or equal to last, because that's the search space from first to last. So as soon as first becomes more than last, you terminate. So the condition during which this should execute is first is more than or equal to last. If that's not true, it means that your item is not found, and you can return minus 1, which is a not found status. Very quickly, we are going to do an implementation of this, where the method is public static int binary search on an array for a target. The first thing you have to check always is if the array is null, you can immediately return minus 1. You can also state the precondition that A is assumed to be in ascending order. If it's not our problem. So this is a precondition. The first index is 0. The last index you'll consider is the last valid index, which is a.length minus 1. As long as first is less than or equal to last, median index is the average of the two. If you find your item there, excellent, you can immediately return that index. If your item is less than the median item, it means in the left, and last becomes median minus 1. If your item is more than median item, it means right, and first becomes median plus 1. Look, I don't really have to check this condition, because if this condition is true, if target is equal to median item, the control has been returned, which means you only come to line number 169 if target is not equal to median. So I can check if it's less than, it's the left half, and otherwise it's the right half. So that's perfectly fine as well. So you modify the search space and repeat the loop. If the loop terminates, it terminates only because first has become more than last, and you can immediately return -1. In my array service, I have a method that generates a sorted array of a given size and a given range. I'm going to use that. So this will create an array for me. In search, I'll create an array using that service, array service dot generate a sorted array, the size of which is, to keep it simple, 8. The smallest item is 1 and the highest item is 10, let's say. Let's just display to see that it in fact creates a sorted array. So the array that is created is 2, 4, 5, 7, 9 and 3 10s, which is great. So it's sorted. Now let's say the item that I'm trying to find is 5. In my searching service class, I can invoke binary search. On the array ARR, where the item is item, the value it returns, I'll store it in index. Now index is -1 if the item is not found, so we'll display item not found, and otherwise, which means it's more than equal to 0, we can display found at index, whatever index is returned. For clarity, let's get rid of everything else in the program and have a go. So if the array is 3, 4, 5, 7, 8, 999, it says 5 found at index 2, which is 0, 1 and 2. That's good. Same again. This time it says 5 found at index 3. You'll notice that there are actually 2 occurrences of 5. But since there are 8 items, first is 0, last is 7, the median is 0 plus 7 by 2, which is 3, and the item is found there. So binary search returns the first encountered index of the item, but it might not necessarily be the index of the first occurrence. What I'll do is I'll change the array such that all the items are 5. When I now run binary search on this, it returns index 3 because that's the first index at which it checked the item. But it's not necessarily the first index at which that item existed in the array. Now you can also apply binary search when the array is sorted in the reverse order. I have a very simple function in my array service class that reverses the array. I'll change the items in the array to be between 1 and 10, reverse the array, and then display it again. So when I run this now, you can see my array is in descending order. Again, it's in descending order, and you can see in this instance the item 5 did indeed exist, but it says that it was not found because it started searching from median, and because the condition is that if the item is less than the median item, search in the left half, it does not find it. So all you have to do to change binary search to perform on an array in descending order is if the item is more than your median item, then it's in the left half because it's sorted in descending order. I'm going to change my client call to binary search descending. I run this. Here you can see now that 5 was found at index 5. 0, 1, 2, 3, 4, and 5. So that's how you perform binary search on an array of primitive data types. One more thing, you can also apply binary search on an array of objects. I have a rectangle class defined in my project. So if I want to apply binary search on a rectangle object, the only change that I have to make is that I cannot perform comparison using primitive comparison operators. So I have to, and of course target is a rectangle as well. So I have to use compare to compare a rectangle with another rectangle. So if compare to returns 0, it means the two rectangles are equal based on whatever criteria there is. If compare to returns a negative value, it means that target is less than the median item, so you search in the left half, otherwise in the right half. That's the only change you have to make if you want to search in an array of objects. Again, what I'll do is I'll create a rectangle array. Now this is a method in my array service class that creates an array of rectangle objects that are sorted in ascending order. The item that I'm trying to search now has to be a rectangle object, so the item type changes to rectangle object. Let's say that rectangle is a rectangle of 4 by 5. Now rest of it works equally or similarly, and I run this. That's my array created, and you can see that it's sorted based on area. A rectangle of 4 by 5 is not found. I run this again, still not found, which is correct. Not yet. And this time you can see that the item was found at index 5. So the only thing that you have to change in binary search while operating on arrays of objects is that primitive comparison needs to be replaced by compare to. Compare to returning 0 means the items are equal. Compare to returning less than 0 means target is less than median item, and otherwise it means it's more than. You can also use the equals method, but of course you have to define equals and compare to in the class that you want to use. So that's it from me, and hopefully you understand a bit more of binary search now, and I'll see you next time. Thank you.